Hi children, good morning everyone. Today we are discussing about relation between refractive index and angle of minimum deviation. See, this looks like it represents a ABC. It's the borders of the prism. So it has two faces. That means AB face and AC face. And BC is the base of the prism. So these are all we have to learn in previous class. Now, this class we have to find the angle of minimum deviation. Whenever the light passing through the air medium to glass medium, that means rarer to denser medium, and again it emerges from denser to rarer medium. See here, when PQ is incident ray, PQ is incident ray, it is and make an angle I1. Make an angle I1. It is away from the it's towards the normal. Towards the normal. Now, whenever the light ray is entered into the prism, it comes deviating. Now, QR is a refracting ray in glass. A refracting ray in glass medium. So, now the normal is extended to prism, then comes O. Now it represents a angle I1 is equals to angle I1 is equals to at phase 1 TQO that is I1. Angle TQO is I1. Now, whenever the refracting is at surface face B, that is AC, at R, angle TRO is I2. TRO is I2. When it is normals are extending N1 to O and N2 to O, the refracting angle at Q is R1. The refracting angle at R is R2 at faces of A and AB and AC. Now here QR is parallel to BC. QR is parallel to BC. That means the refracted ray is parallel to base of the prism. Base of the prism. Now RS is emergent ray at make an angle. It is away from the normal, that is an angle I2. I2. So here the arrow marks is representing PQ is towards normal and RS is away from the normal. So now see, let us how to find here is angle A is angle of the prism, angle I1 and angle I2 is angle of incidence and angle of emergence, and R1 and R2 is angle of refraction of the faces AB and AC. See here, in the above figure represents ABC, the principal section of glass prism. A prism is wedge shaped body made from refracting medium bounded by the two plane faces inclined each other at some angle. It is called as angle of prism. It represents angle A. See here. So total ABC, the angle A represents a angle of prism. Angle A represents a angle of prism. Now a ray PQ is incident on face AB with make an angle I1. Let an angle N1QP is from air to glass medium. It means at an angle made by I1 is, see here, I1. Angle I1 can goes to N1QP. N1QP is angle I1. Angle I1. Now here angle I2 can goes to N2RS and angle R1 and R2 can goes to angle OQR and ORQ. Let us represent here. See, a ray QR is bends towards normal with make an angle R1, angle OQR is from first phase A to glass, and again it emerges at R with make an angle R2, angle ORQ is moving from glass to air medium on second phase. So in the first phase, angle OQR is R1 and in second phase ORQ is R2. So that is a refracting angles in glass medium from A to glass or glass to air. So from R1 represents air to glass medium and R2 represents glass to air medium. That means rarer to denser and denser to rarer. So now the array RS is represents emergent ray from glass medium to air medium with make an angle I2, that is N2 or S. See here, N2 or S. Make an angle I2. So here I1 and I2 is represents a similar angles are angle TQO and angle TROR represent the similar angles of I1 and I2. Let us see here. If mu be the refractive index of glass with respect to air, then the principal section of glass prism, that means the entire glass prism, we have to be called as principal section of glass prism. That is indicated by the refractive index of glass prism is mu. According to Snell's law, mu is equals to sin I by sin R. Sin I by sin R. That means angle MTR is gives the angle of deviation. The angle of deviation. Angle MTR. See here, angle MTR. This is M. This is T. And this is R. So MTR represents a angle of deviation. Angle of deviation. Now AQOR is equilateral triangle. AQOR is equilateral triangle. See here, AQOR. AQOR represents equilateral triangle. See here, equilateral triangle, angle AQO is equals to 90 degrees. Angle AOR is equals to 90 degrees. Angle AQO is 90 degrees. Angle AOR, that means see here, angle AQO 90 degrees. Angle ARO is 90 degrees. Clear? Now angle A plus angle QOR is equals to 180 degrees. That means angle QAR plus angle QOR is equals to 180 degrees. See here, angle QOR plus angle QAR is equals to 180 degrees. That means A plus angle QOR is equals to 180 degrees. Then angle QOR is equals to 180 degrees minus A. This is equation 1. From angle MTR is equals to TQR plus TRQ. That means MTR. That means outer angle is delta. Outer angle is delta. See here, the outer angle is equals to sum of interior angle. Sum of interior angle. So sum of interior angles means TQR plus TRQ is equals to delta. You understand? Angle TQR plus TRQ is equals to delta. Delta means angle MTR. So that's why here we have to write angle MTR is equals to angle TQR plus TRQ. Therefore, angle MTR is equals to delta, angle TQR is equals to I1 minus R1 and the TRQ is equals to I2 minus R2. How will come I1 minus R1 and I2 minus R2? See here. This is entire angle N1QP is equals to I1. Now TQO is also I1. Now we want to represent TQR, that means this angle. So this angle represents, I want to write here, this angle represents I1 minus R1 and this angle represents I2 minus R2. Or understand? So this entire angle is I2. So I2 can substitute by R2 here, and this is entire angle I1. I2 is substituted by R1. It gives I1 minus R1 and it gives I2 minus R2. Let's see here. Therefore, angle MTR is equals to angle TQR in place of I1 minus R1 plus angle TRQ in place of I2 minus R2. Therefore, angle MTR means delta. Delta is equals to I1 plus I2 minus of R1 plus R2. This is equation 2. So, from triangle QOR. So, triangle QOR means, see here, QOR. This is triangle. So in this triangle, total angle is 180 degrees. Then it comes QOR plus OQR and ORQ is equals to 180 degrees. Angle QOR plus angle OQR plus ORQ is equals to 180 degrees. Angle QOR plus OQR means R1 plus and angle ORQ is equals to R2, that is equals to 180 degrees. Therefore, angle QOR is equals to 180 degrees minus of R1 plus R2. 180 degrees minus of R1 plus R2. This is equation 3. Now, you can go equating 1 and 3. 1 and 3 equations we can get. 180 degrees minus A is equals to 180 degrees minus of R1 plus R2. R1 plus R2. Therefore, here 180 degrees and 180 degrees cancel. Then minus A is equals to minus of R1 plus R2. Then we'll get minus minus cancel. Therefore, A is equals to R1 plus R2. This is equation 4. We want A is equals to R1 plus R2. Then if the substitute in the presence of R1 plus R2 in equation 2, then delta is equals to I1 plus I2 minus A. I1 plus I2 minus A. Therefore, A plus delta is equals to I1 plus I2. I1 plus I2. That means here minus A can goes to have left hand side. Therefore, A positive. That means A plus delta is equals to I1 plus I2. This is equation 5. So, we have two equations. We can get A is equals to R1 plus R2 and A plus delta is equals to I1 minus R2. I1 minus R2. Therefore, the angle of deviation of a ray of light in passing through a prism not only depends upon material but also upon the angle of incidence. Hence, it clear that angle of minimum deviation, that means minimum value delta M. That means whenever the light ray is passing through the, here, see here, P, Q or S, when it is opposite direction S or QP, it can get deviation is minimum. It can get deviation is minimum. So here the minimum deviation can be angle made by here NTQ. NTQ. So that's why whenever MTR is equals to NTQ, that means the minimum deviation angle is nothing but angle of deviation. Angle of deviation. When it represents angle of deviation, all the angles are equal here. So angle of incidence I1 from phase 1 is equals to angle of incidence I2 is